if you can memorize the times table up to 15, you're on your way to fully comprehending the basics of doing math well. So if you can understand this, 0 times itself. What is 0?
Nothing.
Really? Let's talk about that.
It's a number.
Maybe I get-
It's a number.
It is a number, you're right.
There you go.
Yeah, mathematician defines 0 as a number. But it's a 0, it's just incredible. They haven't figured it out yet. No, because it works in finance, right? Because it's a placeholder. It could be used to make numbers greater. You start with 1, then you add another 0, you get 10. Then you get 100, 1,000, 10,000, 100,000, a million. So it's going up. So it's a placeholder. But I don't think they've come up with the right definition yet. Okay, so let's say, or any other number, y. So y could be any number, right?
Yeah.
Here's where algebra comes in. Listen. Y could be any number. This course is going to be dealing with these unknown numbers that you can plug in. They're called variables. What does it mean to a variable? What does a variable mean? To change, right? To change. So you're going to be dealing with letters in algebra. X, Y, Z, A, B, C, I, J, K. To represent things that could change. Depending on conditions and depending upon how the problem was given to you. Now the thing is, what kind of method are you going to use to solve the problem? So this is one of the most basics. What is y? Can y be 2 times 0?
Yeah.
Any number. Simple as that. Y could be any number. But you already know through this operator, x means times, or asterisk, or dot. These are the 3 different ways that you can use the operator multiplication. Like this method. The x is not a letter. It's just an operation, an operator that you're going to perform on any y with a constant value of 0. Right? So 0 is your constant.
Parentheses another operator.
Yes, it is too. But we're going to get into order of operations later. All right? So the 0 is a constant for this particular problem. It stays the same. The operator is telling me to multiply the variable y. And I will always get 0 by rule. It's a rule. Mathematics is about rules. Follow rules. You can't go wrong. All right? But you got to learn those rules. So no matter which way I twist it, 0 times y is going to still be 0. So how do I arrange it? Right? It's called commutative property of multiplication. Whichever way I arrange it, it's still going to be the same. So you're going to be in contra these basic rules in algebra with different topics come along. But I have to lay the foundation, or else we're going to be all over the place. Then you're on your way to comprehending the symbols using math to express certain ideas and principles. Did you notice that no matter how you group the numbers of multiplication, the results are the same? Furthermore, if you can comprehend the concept that 1 times any number y in itself is that number y. What is, if I say y is equal to 2, what's 1 times 2? If I say 1 times 5, what is that? All right? So I just stated it in English. 1 times any number y in itself is that number.
But why use y? Why use y?
Well, just answer it. Why? Why? WH1 was it? Use any number. Did it just say that? X, Z. But I have to establish what I mean. They use it. So they use variables, letters, where the number is changing. This is algebra. Once you get that, it's going to be a wrap. Well, hopefully.
I have to pick up my daughter by 2 o'clock, so I have to.
We out here, buddy. We out here. Here we go, because I'm running out of gas too. Before then. Hey, I gotta use brain power, okay? And you can't, I don't charge this up. You charge your cell phone. What do you know how I get charged up? When I go to sleep. Right. One is considered the identity principle. If you fully understand that you have the potential to understand higher concepts, I'll provide you with many examples to do that. All right, let's look at the number line, right? We all know the number line?
Yes.
It's on the X plane, right? X. This is the X. This is the Y plane. The horizontal, the vertical. What is this sign? Plus what?
Infinity.
Correct.
Thanks for some.
And negative infinity. So let's see. Is there such a thing as a negative number?
Yes.
Let's get this straight. See, that's a philosophical question. It really is. Is there such a thing as a negative number? Wow. So you exist, right?
Yeah.
Are you positive or negative?
Oh,
Negative
wow.
It depends on
That's-
your
It depends.
That's philosophical. That's philosophical.
Yeah.
It really is. So, yeah, for real. So, negative just means to take away from what already exists. But it can't really go out of existence. So if you got 10 apples, and I take 5 from you, you got 11.
5.
You got that mentally, right? If I got 10 apples and you take all of it, and you got it. That's how finance works. That's why the banks are taking your money. Because they know these schemes, right? It's a combination of numbers and percentages. So positive numbers continues to element to the right of the number line. Degree sign or symbol for infinity is this. Positive number quantified. Positive number quantifies and describes objects and subjects in the real world. Is this an object? Are you an object or subject? Subject. Because you're a human being, right? What do we mean by objects? Objects can be pencil, cars, desk, furniture, buildings. Subjects are people, children, birds, insects, horses, cats. All right? The negative numbers signify a deficiency or a lack of some known subject or object. The zero fills in a void and brings balance to the positive and negative numbers. The concept of zero was instituted by the Hindu-Arab civilization in ancient times to bring order and meaning to diverse fields of study such as economics, medical science, visual art, architecture, engineering, military science, geology, astronomy, etc. The example below sheds more light on the number line. Plus 5 added to plus 5 equals what? Plus 10, right? But we don't always put the plus signs, right? We take it for granted that it's positive when there's no sign in front of the number. So these are certain assumptions that you have to know in mathematics too. You have to infer certain things that were taught to you. They don't come automatically. Because we are moving towards a greater number when we include or add 5 to 5. Generally, the positive is omitted, and any number plus x or plus y can be represented as just x or 5. The omission of a plus assumes that the number is positive. I just said that, right? The secret to learning math the correct way is that there are just too many assumptions and expectations as to what you know. Furthermore, teachers expect you to know many things that perhaps no one has taught you before, but that you have just plain forgotten. Can we forget things? Cell numbers are one of the things that we could forget easily, right? Because now we're relying on AT&T or Sprint to keep all your numbers straight. It's incredible that we've reached this stage. If you glance at the number line above, you will notice that the negative numbers are to the left on the number line. So minus 5 plus minus 5 is equal what? Let's see why. Minus 5 plus another minus 5. Is the minus 5 the other one moving that way or this way? Exactly. That's all it is. A minus 5 and another minus 5 is taking you more into the minus. You see how that works? But what's a minus 5 plus 5? Damn, you a calculator. That's exactly how I want to get it. Damn, that took me by half a millisecond. No, that's how you're supposed to get it. Like that, instantaneous. Okay, here we go. So examples, minus 7 and a minus 12 is what?
Minus 12.
Huh?
Minus 19.
19,
See it?
negative 9.
A negative and a negative
No, we're not multiplying, we just add it. A minus 7 and plus a minus 12. It's bringing you more towards minus, right?
Yeah.
You see it? Right. And what if I said minus 12 and a minus 7? This is the same thing?
Yeah.
Yeah, you can say
There it is. What's, we already know this one, right?
Yeah.
How about this? You know that too, right? It's bringing you further into minus. And if I reverse these two numbers, it'll still be minus 75, right?
Yeah.
Mathematics consists of rules and principles. Here are some basic rules of multiplying positive and positive numbers. I gotta look at that again. Okay. What's a minus? Okay, here's the rules. A minus times a minus is what? Positive. Times. We're not dealing with addition. We're dealing with multiplication.
A what? You said
A minus number times a minus number equals what kind of number? It says it, a positive number. And that's a rule. Do you commit it to memory? And then you practice on it? Yes. So you have to know how to apply certain principles and rules in mathematics at the appropriate times. What's a minus times a plus? By default, by rule. It's a minus. It's a minus.
Say it again.
A minus is here. A minus times a plus. It's a minus. We're dealing with multiplication. What are the 4 operations in mathematics? What's number 1?
Addition, subtraction, multiplication, and division.
There you go. So, if I say minus 8 times minus 8, what's the answer?
64.
Who says 64? What is positive? Like that, right? Right? Remember we just said that? We take it for granted that it's over. So this is rule. You want to take the philosophy of mathematics, and you might get an answer from a philosopher about why this is so. So how about a minus 8 times a plus 8? What's a minus times a plus?
Negative 64.
Exactly. And you know the rest. And the plus times the plus 8 is what? Which is the same as this, right? Which is incredible. So you don't have to get into any mysterious explanation or philosophy behind all of this if you follow just principles, okay? And I think that's what happens with a lot of people. They don't like math because it's just too many rules and principles. It's too abstract to them. But you take it piecemeal. Right? Learn the basics first, and then you build. Solve a problem with the method that you're comfortable with. However, always know at least two other ways to solve the same problem for backward. Make up your own problems on a separate worksheet for practice by following the above rules. Good, right? Counting, and this is important, counting systems. What number system do we use to count? What number system do we use to count? Anybody ever told you that?
Count?
How many fingers do you have? How many fingers?
5.
Using addition.
5 plus 5, 2 hands, right?
Addition.
No, we're just looking at the Western civilization of counting systems. The Mayan civilizations in Mexico and Guatemala, they use a base 5 system. Right? Western civilization has elected to use a base 10 because your 2 fingers, your 2 hands, right? Is that right? 5 plus 5, right? Base 10. Base 10. The Ethiopians use base 13. Try to figure that one out. And the Babylonians use base 12. Right? So you got a lot of these Roman alphabets like this. That's a 7, you got X is 10, X1 is 11, so forth and so on. 12, right? So there's a translation between base systems. So the Babylonians use base 12, the Mayans use base 5 or base 20 and multiple. We use base 10. Hindu, Arab. Hindu, Arab base systems of counting. That's what we're going on. All right? So it didn't come in the vacuum, it was created. What base system does a computer use? The central processor. So you got two numbers, 0 or 1. So that's what? Base what? Exactly. She's pretty good to science, it's base 2. She just figured it out.
You said base 2?
On the fly.
Okay.
She learned someplace that the computer.
I didn't even know that
It
Thank you for that information.
It is. It's base 2. All right? And we're not going to get into it's moving through logic circuits. The same logic that you studied earlier, all that stuff, that's what's happening with the computer. So, have you ever wondered where and how our number system originated? Someone showed you and you took it for granted and never thought of it again. Did it ever occur to you what the number 10 in itself means?
10 is a powerful number, though.
It really is. So if I have 10 pieces of chalk, what does it mean? It's 10 pieces in base 10 arithmetic. But it could have been symbolized to something else in one of the bases. It's not easy stuff.
God cipher divine?
Huh?
God cipher divine.
Everything is encipherment, encryption, How do you want to code the world in your culture? Did it ever occur to you about the number 10, right? We mentioned that numbers are used to quantify and describe objects and subjects in the world of human experience. Perhaps it doesn't mean anything to the birds or the bees, as they have their own system of recognizing and grouping things in nature for survival. However, we have inherited ways of calculating and measuring that we experience as a society. These calculations assist us in building bridges, houses, pyramids, television sets, computers, and helps in creating the field of chemistry, biology, astronomy, economics, etc. I pose this question: what do you think would happen to our economic system if we no longer got $10,000 in the bank? Is it still $10,000? If you're not counting the base 10 anymore? So what's the basic unit of monetary exchange? What is currency based on? What coin? What coin? Percent. Okay. So you rather have 100 pennies in your pocket to make a hole in it, or just $1? About that?
Yes, $1.
So you see, let's begin by using the numbers, right? 0 to 9, right? Notice that after you count to 9 and add 1 to it, you get the number 10. So once you run out of 9, you add another one, you get a 10, right? So you're recycling the numbers from 0 to 9. In other words, the numbers are being reused from 0 to 9. What do you think happens when we add 1 to 99? What happens when we add 1 more to 99? So you're increasing the powers. You see how that's happening? So we recycle numbers, that's all we do. Why not? We recycle alphabets. Okay. Well, I think you're getting the gist of it, right? You're getting the gist of it, right? You're getting the brass tacks of it, right? The numbers are actually increasing as you move from right to left, and we consider 10 to be the basic base for our number system that originated with the Hindu Arab world. Take the number 5,100 or 5,100. It means 5,100. The 5 is in the thousandth place, the 1 is in the 100th position, the next 0 is in the 10th place, and finally the last 0 is in one's position. It looks like the following, right? 5,000, which is 10 to the third. This is an exponent, right? 10 to the third just means I've added 3 zeros. This is a scientific notation, an easy way to express large numbers. Then you got this space here, right? This is 1,000's hundreds. See the hundreds? 10 to the second power means 100. You add 2 zeros. What is this? The tens. 10 to the 1 is 10, right? And what was our original number? 5,100. And then the last one is the ones. So 10 to the, any number raised to the 0 power is 1 by root. By root. A lot of this has to do with rules and memorization of rules, through practice, right? Recognition of powers of numbers. Powers or increase of numbers is a mystery to most people because modern civilization inherited the base 10 number system. You count with 10 fingers and 10 toes. Ancient civilizations like the Babylonian and the Roman Empire counted using a base 12 number system. That is why we have the 12 signs of the zodiac and the 12 hours to half a day. Their symbols look like the following. Remember I said it before? Yes, yes.
You said scientific notation is the easiest way to what?
Express large numbers. Yes. So as you can see, a society of people come up with a scheme to express quantities in their everyday interaction with human beings. The 5 above is unique, thus the Romans felt like using that symbol to express that quantity. And the 1 before the 5 indicates that the number is 1 less than the 5. The rule is never to use more than 3 as one is a succession. If you do, a new symbol has to be created. What do you do? What do you think happens after the X111? Exactly. 14. So we see the rules that they use. All right? And you can actually teach yourself this. Here's a scientific notation that you was asking me about. Numbers like 1 million can be written as 1 followed by 6 zeros. It can be written as this. 1 times 10 to the 6. It's a million, right? The same can be said about writing scientific notation for very small numbers. So 1 times 10 to the minus 6 is 10 to the minus, so it's getting smaller and smaller and smaller and smaller and smaller. And it can be expressed like this as a fraction. See it? So we spoke about the origin of the word mathematics, right? When we examine the etymology of the word origin of the word mathematics, the prefix math is derived from the Hindu and Egyptian meaning for matter or ma'at, meaning matter or the nature or the physical and material content of the universe. Arithmetic can also mean rhythm and to measure because rhythm is the key of life that creates patterns and repetition. So there is mathematics and music as well. So you have to label notes, and notes have vibration at certain frequencies. So personal words of wisdom. Math measures human experience and events that occur in nature. Arithmetic and rhythm and repetition are the keys of life. Develop strong mental calculation skills and you won't regret it. The brain is hardware and the mind is software. Yet both of them is simple practice. Practice makes perfect. Skills built in practice and teaching are essential ingredients in good problem solving. Okay, read the first one.
It doesn't make sense to pick up things to solve a problem and you have no idea how to approach it.
Time out. Let's have a discussion about it. What does that say? Read it. Ms. Goodwin, read it, Ms. Goodwin.
It doesn't make sense to pick up a pen to solve a problem when you have no idea how to approach it.
Is that true? If you got nothing to say in the essay, you give it a topic, what good is a pen? Aren't you going to sit right there and just stare at the pen all day? I'm dead serious. It could sound sarcastic. What good is a car if you can't drive? Same thing. Read this one.
Oh, an algorithm is an Arabic word that means to solve a problem step by step.
Here it is. Algorithm. This is what all these programs are doing to you, all these applications. These applications are nothing but small algorithms. Algorithms are steps that you take to solve a problem. Applications, same thing. Computer, read the next one.
Computers are programmed for all company
Right.
with a large
Set of instructions to solve your problem. That's a reflection. Intuition and problem solving is gained through trial, practice, and experience. Have faith in yourself. Size up a problem and make a good approximation of the answer before picking up your pen to solve it. What am I saying there? The next to the last statement. What is that saying? Can you interpret that for me? The next to the last one? Size up a problem? What do you mean to size it up? Look at it mentally. Oh, wow, I did that problem in homework assignment number 2. All right, so you calculate it mentally, right? Because your brain is a computer, right? And you develop somewhat. And then you develop it through practice and learning. And teaching as well. You get stronger by teaching. So once you have an idea mentally, then you can start to slow down and write it. All right? Or you can do the reverse process. Write a problem down carefully and then commit it to mental computation. All right? A short, okay. Oh, Paul, read this one.
Short pencil with
Louder, louder.
a short pencil with a sharp point is much better than a long pencil with a dull point.
What is the last thing you say? You understand that one? What's the last one saying? Use your logic. Those are 2 quantitative reasons. Something to do with the tool that you're using as a pencil. So if you got a sharp pencil that still got a left point, you can solve a problem, right? But then somebody might come up to you and have a bigger pencil than you. But you got no point. So you can't solve the problem. You can't solve it. You got no point. I don't care how big you are. So size doesn't matter. That's what I'm saying. So preparation, but it should have been no point at all. Because a more pencil has no point. Further notes on math. I'm here to teach you math through practice and will provide insightful ways to look at math. I will earnestly attempt to make learning math fun. Don't forget to make up your own problems. Once you have learned certain problem-solving techniques and methods. In other words, I will instill in you the ability to be creative. So now we're getting into the math part of it, right? Operators and operands. I spoke about that earlier, right? These are operators. Add, subtract, divide, multiply. The addition and subtraction signs will always be the same. However, you might experience other signs of multiplication and division. Here they are. Division. Here they are. You've seen these. The first thing that you do to solve a problem presented to you is to recognize the operator and what type of operation is to be performed. Okay? So here we are. Operands are the numbers, unknowns, or variables that are to be operated. Okay? So look at the rest. Read the rest.
But everybody, they don't have random thoughts. Not everybody. Everybody got random.
See it? It's good? Right? It'd be good. You like me to send you this?
Yes,
Okay.
yes, please.
All right. So these are different, what they call equations, and way to solve these problems. We're going to try to solve some basic problems before we leave. We should be out of here, about 20 minutes. On the handout that I gave you?
Can I have it?
You really go.
Yeah. I'll write it on. It's on the syllabus. Okay. Oh, you didn't get, who else? You
They
didn't get
wasn't
syllabus?
here.
Oh my goodness. That's right. Good. So we're looking at, okay, so when you do the matrix, you get the common factors of 2, right? So you go, when I send you the PowerPoint, you can look at these, all right? Carefully. I'm just trying to get to some problem solving. Yeah, I think that was it. Okay, good. All right, so let's look at the handout, right? Just have to read that. Preface to the instructor. Okay, so turn the page and look at the preface to the student in here. Let's read that. Who wants to read? All right, this is the author speaking to you before the textbook even begins to teach these kind of topics. So, you want to read? So, just raise your voice a little bit.
I often find my students asking themselves the question, why can't I understand this stuff the first time? The answer is you're not expected to. Learning a topic in mathematics isn't always accomplished the first time around.
Everybody get that? You're telling me the truth. Student comes up and says, they see the problem for the first time and they just can't get it.